All right, in this problem, Ralph is a fund manager, and so is Fred. And first look at how well Ralph did. Ralph's stock portfolio has a beta of 1.75, and it earned a 12% rate of return last year. The standard deviation of the portfolio returns was 15.7% during the period. The risk-free rate for that year, 1.6%, and a total return for a comparable market index was only 7.2%. All right, so Fred's stock portfolio only earned 10% against the same benchmark market index, so it did worse. However, the standard deviation of Fred's portfolio was also lowered 11.5%, and the beta of his portfolio was also lower at only 1.2. So given all this information, what we want to do is compute the Sharpe ratio, the Treynor ratio, and the Jensen's alpha for each portfolio, so we can comment on which one of them is actually doing better. Treynor, R-E-Y. All right, so first we'll start writing down the information we have for Ralph and for Fred before we start doing any computations. The fund return, Ralph earned 12%, Fred earned only 10%. The risk-free rate for the period was 1.6%, so the fund excess returns, the return over and above the risk-free rate, would be 10.4 for Ralph and 8.4 for Fred. Alright, so what else do we have? We've got a standard deviation of the portfolios, or the fund. We just call it the fund. It was 15.7 for Ralph and only 11.5 for Fred. I also know that the market index return was 7.2%. Which would be the benchmark both Ralph and Fred are measured against. So the risk premium for the market index would be the excess return over the risk-free rate. So that's a risk premium of 5.6. The beta of Ralph's portfolio is 1.75, and the beta of Fred's is 1.2. All right, so now that I have all that information, I can calculate the expected return under CAPM, the capital asset pricing model. That would be the risk-free rate plus the beta times the market risk premium. So normally we would have expected an 11.4% return for Ralph if he simply matched the market, and an 8.32% for Fred if he simply matched against his market index. All right, the Sharpe ratio is the portfolio standard deviation, the excess returns of the portfolio divided by the standard deviation of the portfolio. So we've got a Sharpe ratio of 0.66 for Ralph and 0.73 for Fred. Now this is the ratio of excess returns over the standard deviation of returns for the portfolio. So excess return divided by standard deviation. The higher the number, the higher the return per unit of risk. So the higher the Sharpe ratio, the better, and in this case, Fred's doing better. If I go to the Treynor ratio, it makes an adjustment by taking the excess returns and dividing them by the beta of the portfolio, which is a measure of the systematic risk. The Sharpe ratio is measuring the excess returns by the total risk. The Treynor is just looking at the measure of systematic risk. So we take the excess return for the fund and divide it by the beta. It scales it by how much risk you were taking, or unsystematic risk, the part you can't get rid of. And again, higher is better, so in this case, Fred was doing better. And then Jensen's alpha is simply the actual fund return minus the return predicted by the capital asset pricing model, which is already adjusting for excess returns. That's Excel acting up. Let me format that so we can see it without the 17 decimal places. And Ralph earned higher than the expected rate of return by 60 basis points, but Fred beat him handily with a 1.6% alpha. Alright, so what this is telling us is that Ralph earned a higher rate of return than Fred, but he took a lot more risk to do it. So on a risk-adjusted basis, Fred is better in all of these measures that we use.